In the world of superheroes, it's hard to top Dr. Manhattan. Functionally immortal, Dr. Manhattan can teleport over vast distances, create energy fields, manipulate the molecules of anything, including his own body, perform telekinesis, reverse entropy, and defy virtually all known laws of physics. For all intents and purposes, he's God. No, actually, he's Achilles, because he does have one weakness. What could this possibly be? Dr. Manhattan's only weakness is the tachyon, a theoretical particle capable of traveling faster than the speed of light. But just like Dr. Manhattan, tachyons can't exist. Nothing can beat the speed of light. Or can it? Can you beat the speed of light? First, let's define the speed of light. The maximum speed of light is 299,792,458 meters per second, but that's only in a vacuum when the person measuring is right next to the wave. Or is it a particle? Let's move on. The letter used to represent the speed of light in physics is c, so let's just call it c for the rest of this video. Where else have we seen this c pop up in? Oh, of course. E equals mc squared, part of Einstein's theory of special relativity. The theory of special relativity proposes two facts, or postulates: that the laws of physics remain the same in all inertial reference frames, and that c is constant. Therefore, in order for special relativity to be correct, c must remain a constant in a vacuum. When objects approach the speed of light, or even a significant fraction of it, you start to notice that the nature of energy and motion in the object begin to differ a bit. At such speeds, kinetic energy gains a new equation. This one. Seems like a mouthful at first, but bear with me here because we're not actually going to solve the equation, we're just going to draw a few simple conclusions from this. Focus on the bottom right corner of the equation with the v. For a normal particle, one that never surpasses the speed of light, everything should check out just fine, and plugging in all the variables should result in the energy of the particle. Now enter the world of the tachyon, which travels faster than light. If that's the case, then its velocity, which is the v, should be greater than the speed of light, c. Wait, wouldn't that mean that v squared over c squared is greater than 1? If the numerator is greater than the denominator, then the answer to the problem should be greater than 1. But wait, we have to subtract this value from a 1. You can't subtract anything greater than 1 from 1 unless you want a negative answer. The denominator can't be negative because there's a radical here, and radicals can't have a negative number inside. That's an imaginary number. If the denominator is imaginary, then E has an imaginary value, and energy can't have an imaginary value. And if we follow the equation I listed before, tachyons would in fact gain energy in order to slow down, whereas if they were to lose energy, their speed increases, which is the opposite of normal matter. As v increases, the denominator increases, meaning v increases as energy decreases. That doesn't make any sense. There have been experiments in the past that show the speed of light as being different, but as Mikio Kaku pointed out, the errors are not in the calculation and analysis, but in the experiment itself. C is only constant in a vacuum. In the end, anything with mass is immediately banned from surpassing c. Of course, there are cases in which parts of a wave of light travel faster than the frontal velocity of the wave, but that's beside the point. No particles in the sense of tachyons exist moving faster than light. So Dr. Manhattan can rest safer now. Oh wait, he can't. John Osterman is in an even worse situation than his archenemy. Teleportation, creating life, transmuting matter, practical immortality. If Dr. Manhattan did exist, he'd break all the known laws of physics, and if he wanted to, make the entire universe his sandbox. He is, like many other superheroes, an impossibility, at least to modern science. Modern science is excelling faster than ever, so quickly new discoveries are popping up every single day. We're learning about the world more than ever before, and we'll need to know the laws of physics and the models of nature that explain biology, geology, and astronomy, but as we expand our circle of knowledge, we only begin to see more of the unknown. If our theories and models are forced to change with the evidence, then they'll have to change. Maybe someday we'll be able to get to different ends of the universe via wormhole, move at the speed of light, manipulate matter, and do whatever Dr. Manhattan can do, virtually playing God. We'd be pushing the limits of knowledge and what we can do. But wait, aren't we already doing that? Thanks for watching.